Hello and welcome to this tutorial, and in this tutorial I'm going to show you how you can bring instances from Blender to Unreal Engine. So by instances I mean uh, duplicates of the same geometry that are not necessarily new objects but rather transforms of the same object that are oriented differently in the scene. Uh, I'm going to show you how you can take those from Blender and then import into Unreal Engine and then convert them into ISMs or any other, instancing setups. And I am also going to cover how you can bring, in the same way, how you can bring instances that are created with geometry nodes that are created with any procedural system that is using instancing and then using the same geometry to populate the scene. Let's talk a little bit about the motivation behind this. Why would we want to link the duplicates together? When creating large scenes, you basically have three options. So either you can merge all of these meshes together, or you can keep them as duplicates, or you can keep them as linked duplicates. So merging is the most costly one, and then comes duplicates. And in case of Blender, the advantage that we have in linked duplicates over the normal duplicates is that the storage space and the rendering speed up. So if you have a lot of instances that are linked together, then they load very efficiently and they render very efficiently. That is the motivation behind doing this in Blender. As per why would we want to do this in Unreal Engine, there's a lot of talks, there's a lot of videos and a lot of documentation explaining this. Basically, it comes down to draw calls. So if you have something like instant static meshes or anything like Foley's actors, then the GPU can render a lot of these instances in a single draw call. So that is what we are getting at. So if we have a lot of static geometry and they are not merged together in a instant static mesh, then each of them are going to be rendered with a single draw call. So that is quite expensive. So in order to save that performance cost, we can use instant static meshes, and there's a lot of other abstractions in other game engines. Every one of them has them, and then that is making use of the functionality of the GPU, the ability of the GPU to render a lot of objects in a single draw call. So that GPU parallelism is what we are trying to exploit. Each instance of these actors are just storing a unique transform, and then within these, anything unique about the ISMs is they just store transformation. So the scene is basically made out of 7 static meshes and the materials and the textures. So this is a great way to populate a lot of large scenes without having a lot of static meshes or a lot of actors in the scene. Let's actually see how to do this. So let's start. Now, before we begin, we need to make sure that the duplicates are actually linked together, and then Blender knows that they are duplicates of the same objects. So let me show you what I mean. If I look at this rock, so this scene was created in Gravity Sketch by taking a bunch of Megascans assets, and then I just duplicate them. I place them at different locations, orientations, and I scale them up or down, and then I cover the whole scene like that. And somewhere in the importing process, this got messed up, and then these are not actually linked as duplicates, and they are represented as unique pieces of geometry. So if I select one of them and select linked and object data, it's not going to select all of the other rocks, which, as a matter of fact, I know that they are duplicates of the same rock. So the first thing we need to do is we need to make sure that these are linked together, and Blender knows that they are derived from the same mesh resource. So there are two approaches you can take for doing that. So if you have a clear scene organization, or if you have a clear naming pattern, or you have organized things into collections, then what you can do is you can you either select them manually or through the collections. And then, so let me demonstrate it. Select the rocks manually, and after you've selected all of them, at the last rock you go to object and link object data. So what this is going to do is it's going to take the object data, the mesh data from the last object, and then it's going to link it over to all the previous selections. So if I now select one of these and select linked object data, it's going to select all of them. So this approach of manually doing this is feasible when you have a clear scene organization, or you have a clear collection, or you can select things manually. Where this gets problematic is when you have really big scenes and then you did not bother with organization. You were just working and you were just duplicating stuff randomly. You were not linking them while duplicating them, and the things are all over the scene, and then you clearly don't have any means to select all of them. Even if you did, it would be really tedious and quite the headache. So in order to save that time and save the headache, I've created a small Python script that does it for you. So I'll put a link in the description. You can go to the release section and then grab a zip file, and then you install it like any other add-on. And then after you enable it, let's say it's called Instance Harvester. And after you've done that, you will find an option here on the object. If you go under object, and then you will find an option to relink duplicates. So what this is going to do, it's going to scan your scene, and then it's going to find all the meshes that have the same statistics, like they have the same number of vertices, they have the same number of edges, or they have same number of faces, and it's going to group them all together and relink them, and you don't have to do anything manually. So you just click this, or you can find it in the operator search, relink duplicates. And if you expand the operator options, you have the option to operate on selector. So this is useful if you have a really big scene and you don't want to mess anything up, and you just want to operate within a selection or within a collection. You can use that option. And there are some edge cases where you have the same geometry, but you have different material. So you have, let's say you have a decal plane that has the same number of vertices, faces, and edges, but it has a different texture on it. So in that case, what you can do is when you run the operator, you make sure that this is checked. So when this is checked, it makes sure that the instances have the same matching materials. Otherwise, if they don't, then it's going to treat them as different objects. So you won't run into that problem. But either way, this can mess up your file. So make sure you have a duplicate of your scene before running this. So after I've run this, now if I select one of the pieces, the ground covers, and I select linked object data, it's going to select all of the instances that were created from that geometry. And now let's go over to the geometry node setup. So what I have here is a very simple scattering setup. So this takes one of the rocks, and then it samples the positions from the vertices of a simple plane object, and then it subdivides it, and then it rotates it, scales it randomly, and then positions them all around the scene. So this is very simple, but this can go as complex as you like. Doesn't really matter, as long as it is using the instances of the same object. This will work. I will show you how you can also bring these instances into Unreal Engine. After we've done that, we've linked everything together and it is all good to go. We want to go to File, Export, and we are going to use the GLTF format because it allows us to export the geometry node instances, and also it doesn't have some quirks that comes with FBX. So we're going to use GLTF, and then in the operator options, we make sure on the data scene graph, we make sure to select the geometry node instances. So if we check this, it's going to export all of the instances of the geometry node setup as instances of the same object. So you go ahead and check this. If you don't want to export the input plane that was used to derive these points, then what you do is, when exporting, export. So you make sure that the geometry node instances is checked, and then under mesh you make sure to select apply modify. So what this is going to do, it's going to place an empty in place of the plane that we use to derive the geometry node points for. And after we've done that, we can go ahead and export it, and we are almost done. And before we move on to Unreal Engine, there is one thing we need to do. Let me delete everything and then re-import what I just exported. So if I re-import this desert.glb, that is what we just exported. And if I select one of the object and then one of the rocks, and then I select linked object data, we see a problem here. So even though these instances were created by duplicating the same object, they are not linked. This is a small quirk with the exporter. So in order to fix this, what we need to do is we need to re-import the file just like we did, and then we need to run this relink duplicates once again. After we've done that, if I select one of the rocks and then I select linked object data, it's going to select all of them. So that fixes the problem. And then we export it again with the same settings, scene graph, geometry node instances, and then apply modifiers. And then we can just override what we had, the file that we had earlier. So yeah, that is about it in Blender. I will see you in Unreal Engine, where I will show you how you can bring these into the level, how you can create instant static meshes from these. So I'll see you in Unreal Engine. So welcome back. We're in Unreal Engine, and I'm going to show you how you can bring the instances that we just exported and convert them to instant static meshes. So let's create a new level, and let's create a blank one, and then I'll delete this. And what you want to do is you want to do file and import into level. So you don't want to go into the asset browser and then do the import into game. You don't want to do that because we want the instances and we want the transformation that is associated with each of the instances. So we want to file, import into level, and then I will look at where I exported. And then I select the one that we just exported, the desert.clb, and then I click open. And then I select the folder where I want to select the static meshes that are going to get created. And then I just created a temporary folder. And then I hit OK. And you can leave it as it is and just hit import. So as you can see, there are only 7 unique pieces of geometry, but we have populated this huge scene with instances of the same thing. So if I select one of the object and I look at the static mesh resource, it's going to point to all of them are going to point to the same rock asset. So we have successfully exported instances from Blender to Unreal Engine. So to take it a bit further, so this is already good. This already reduces a lot of overhead for us. And if you have any sort of batching in the S-load system, it's going to take care of these instances, and then it's going to batch them together and load them and unload them. But if you want to do that manually, I will show you how you can create instance static meshes from these arrangements of rocks. So let's delete this one. Let's delete the mannequin, and what you want to do is you want to select everything under the scene hierarchy, and then we go to modeling, transform, and then we select harvest instances. So what this tool does is it recognizes instances that are made from unique pieces of geometry, and the ones that are just duplicates. So we can merge them into a single actor. So let's do that. And then I'm going to select ISM for now. You can choose whatever you want. And then I hit accept. So after I've done that, it has created a blueprint for us with a bunch of ISM components and everything in place. So we don't have to do anything ourselves. If you want to convert this into a reusable blueprint, you just hit this button, and then you can rename it. Let's rename it to Desert Blueprint or anything that you want, and then select it. So this is going to create a reusable blueprint from all of those instances. And you can export this blueprint to UEFN with the migrate tool, and it's just going to work. And so now that we have this blueprint, before we do any exporting, I want to give you a word of caution. A word of advice is that how does the collision work? If I now play this, it appears to be working. The collision is derived from the colliders that are set up for the individual static meshes. So let me go out, and then if I open one of the rocks, go to play a collision, it's going to create it's going to show what the collider is made out of. So if you don't like the collision, or if you think that it is not encapsulating your mesh properly, you can regenerate it and then reapply it, and the same collision is going to get duplicated across your scene. Duplicating the colliders that many times is very costly. So if you have a tight performance budget and or you have a frame target that you need to meet, and then you cannot afford a lot of overhead on the CPU side, which is what happens when you have a lot of static meshes that are instanced in the scene. What you can do is you can turn off collision for the smaller pieces. So anything that doesn't need collision on its own, it's just there for populating the scene and make it look dense and lush. You can just disable collision on those. So the way you do that, if I want to disable collision on these ISM rocks, then I can just go down here, and then on the collision presets, I select no collision, and then I save it. So after I do that, it's just going to instance the meshes, and it's not going to bother with collision. So that is something that you need to keep in mind. And if you have a really large scene and then you have really complex objects that the character needs to step on, the best approach would be to turn off collision on each of the instance static meshes. So you turn it off on everything, and then you create a custom collider. So you create either in the engine, or you bring in a custom collider, and then you put it inside this hierarchy, and then you set it as an invisible collider. In the case of really big patches of ground and assets that the player is not going to walk over. So let's say that someone is going to walk over here, but it is where that so the player is going to walk over here. So this is a lot of wasted collision and then wasted colliders for the physics simulation. So in order to avoid that, we just plop two cubes in here, and then we just add a custom collider for the ground. So that is one optimization that you need to keep in mind before exporting anything or using it in game or any other production environment. So yeah, that is about it. It's been a long one, but it's a really important one if you want to create a really large scale scene, so without a lot of performance overhead or that comes from just duplicating things. I'm also working on an Unreal Engine plugin that is going to automate all of this. So it wasn't a lot of steps, but if you have a really large scene and you need to group them and then convert them to blueprints, then it is still a bit of tedious work. So I'm working on that as well. So if you want to get a hold of that, make sure to follow me on all the socials. If you run into any problems, feel free to comment down below and I will answer them for you. And you can also DM me on Twitter or anywhere else you'll find me. If you like the content, consider subscribing and using the creator code BlockyBard in the Fortnite item shop. So yeah, thank you for sticking around and watching to the end. I'll see you in the next video.